In this episode, we're going to look at how to configure dynamic trunking protocol. I'll show you how to do it, and we'll talk about the concepts along the way. As the number of switches in a network increases, the administration necessary to manage the VLANs in the trunks can be challenging. To ease some of the VLAN and trunking configurations, trunk negotiation between network devices is managed by the dynamic trunking protocol, also known as DTP, and is automatically enabled on some of our Cisco switches. We're going to look at configuring trunk links between the switches. We're going to assign ports to VLANs and verify end-to-end connectivity between hosts in the same VLAN. We're going to configure trunk links between the switches, and then we'll configure VLAN 99 as the native VLAN. We'll be discussing configuring static trunking and configuring and verifying our DTP, our dynamic trunking protocol. Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. This episode is part of my series on configuration examples for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. Configure DTP. In this lab, we're going to go through and set up some dynamic trunking protocol. On the left side, I have our work area where we can see our topology, where we're going to configure our devices. On the right side, I have our instructions. The very bottom right is the original packet tracer activity window that opens up when you open up your packet tracer activity. The upper right is the Word document of those instructions. There's several questions we have to answer in this lab. The Word document allows me to enter my answers in and save those answers. We have our addressing table here. We can see that we have 6 PCs. They all have an IP address. Look like they're on different network portions. We can see that the third octet is different in several of them. We got a 10, a 20, and a 30. And then we have some switches. Looks like those are on a different network also. That third octet is different. Our objectives is we're going to configure some static routing, static trunking, and then once we're done with that, we're going to configure and verify some dynamic trunking protocols. Our instructions, part 1, verify LAN configuration. On S1, go into privilege exec mode and enter show VLAN brief command to verify what VLANs are present. I'm going to go ahead and click on S1. I make the window a little bit wider going right to left. It helps the layout of the information. Press enter, takes us into user exec mode. Type enable to get into privilege exec mode. Here we can go ahead and type our command, show VLAN brief. Here we have a number of VLANs. VLAN 1 is the default one that's configured automatically when you turn on your device. VLANs 1002, 1003, 1004, those are also automatically configured. VLAN 1 and 1000 VLANs, you can't delete, you can't rename. There are 2 additional VLANs configured on here. One is the 99 management VLAN and the other one is the 999 native VLAN. These are the 2 ones that have been configured on our switch. Now we need to repeat this on switch 2 and 3. I'm going to go ahead and minimize switch 1, click on switch 2. Type enable to get into privilege exec mode. Then we can enter our command, show VLAN brief. And we have the same VLANs. VLAN 1, 1002, 1003, 1004, 1005 are the default ones that are created automatically. And then VLAN 99 and 999 have been created also on switch 2. Let's look at switch 3. Enable, show VLAN brief. Here we have the default ones, plus we have the 2 additional ones, 99 and 999. Question is, what VLANs are configured on the switches? So not the default ones, but what ones are in addition to those defaults? And that would be VLANs 99 and 999 are configured on the switches. On to part 2, create additional VLANs on switch 2 and switch 3. Now, The command here, VLAN followed by a number, that creates the VLAN. And then once we create the VLAN, we can come in and we can name it. And so for part 2A right here, they're going to have us create VLAN 10 and then name it red. I'm going to go ahead and minimize our S3 window, open up our S2 window again. Now to create that VLAN, we need to be in global configuration mode. So I'm going to go ahead and type configure T, configure terminal, hit enter. Now we're in global configuration mode. At this point in time, we can go ahead and create that VLAN. VLAN 10. It creates it, then we can enter it into it. If you notice, our command prompt has now changed. We are in a configuration of VLAN mode. Once we're in there, we can go ahead and type name, and then we want red. It is case sensitive, so make sure you do get a capital R on red. Create VLANs 20 and 30 according to the table below. And so we have to go ahead and create these on switch 2. Go ahead, type exit out. Now we can type in VLAN 20. That creates it. We enter it. We can now name it. VLAN 20's name is capital B blue. Now, instead of having to type exit and then come back and type VLAN 30, what we can do is just type VLAN 30 and it creates it and takes us right into VLAN 30. So VLAN 30. How do we know it worked? Well, with the Cisco operating system, if you did something wrong, it will let you know. If I had a typo in there or that was a command that we couldn't execute here, it would let us know. Seeing as we didn't get any feedback here, the command works successfully. In the Cisco operating system, no news is good news. And so we got no news, so we are in VLAN 30. We can go ahead and name that, and it's capital Y yellow. That takes care of part 2B. On to part C, verify the additions of the new LAN with the show VLAN brief. Now this needs to be done in the privilege exec mode. We are currently in VLAN configuration mode, so I type in exit once, that takes us to global configuration mode. Type in exit a second time, we are now in privilege exec mode. We can type in show VLAN brief. We can now see that our 3 VLANs, VLAN 10, 20, and 30 have been created successfully. Let's verify that the right numbers, the right names, spelling's correct. That all looks pretty good. Question, in addition to the default VLANs, which VLANs are configured on S2? Well, once again, the default is VLAN 1, and the other default is 1002, 3, 4, and 5. The ones that are configured are 10, 30, 99, and 999. That gives us our answer of VLANs 10, 20, 30, 99, and 999. Repeat the previous step to create additional VLANs on S3. I'm going to go ahead and minimize the S2 window, click on S3, brings us into that. We need to get into global configuration mode, so I'm going to type config T. From here, we can go ahead and type VLAN 10, it creates it, and we enter it. We can name that capital R red. VLAN 20, name it capital B blue. And VLAN 30, and we can name that capital Y yellow. Let's exit out once, exit out twice, and do a show VLAN brief. And here are 3 VLANs. Oh, I spelt yellow wrong. I have to go in there and change that. Okay, get into global configuration mode by typing config T. Then we have to go into VLAN 30. And so I'm going to type VLAN 30. And then we're going to go ahead and retyping the name. So to fix it, all I have to do is enter in that name command and it overwrites that value. So name, capital Y, yellow. That looks good. Exit out, and then a show VLAN brief. 10 is red, 20 is blue, 30 is yellow, and yellow is even spelt correctly. That takes care of all of part 2. On to part 3. Assign VLANs to ports. Well, we've created those VLANs using the VLAN command. Now we have to go in and assign ports to use those VLANs. So we have to actually go into the interfaces. Here we can use the interface range command. As you can see right here on switch 2, we're doing fast Ethernets 1 through 8. We're going to do all 8 of those ports. You could go into each port individually, turn it into an access port, attach it to a VLAN, but we could use the range command and do all 8 of those. And so what we're going to do is we're going to go on switch 2 first, and we're going to do all of switch 2 just because we'll be in there. So I'm back in switch 2. First thing we need to do is go into global configuration mode by typing config T. Now, we're going to work with our interfaces, so it's interface, and then it's a range of addresses at this point. This is where we're going to use the keyword of range, and we put in the first in that range, so F0/1, and then it's a space, 0 space, and 8. Now, when you use the range command, it doesn't have to be continuous ports. It can be 1 through 8, but then say we have to put in there 21. You could put a comma, a space, F0/21, and it would be all of those ports. But for right now, for this exercise, we only have to do ports 1 through 8. I'm going to go ahead and hit enter. Now, notice our prompt. We're in the configuration of interfaces, but we have the range. Right there, it's saying we have a range of addresses. Any command we enter in now applies to all of these ports. Ports 1, 2, 3, 4, 5, 6, 7, and 8. 1 through 8. Now, we can go ahead and turn them into an access port. Once again, we have the choice between an access port and a trunk port. An access port is where you connect an end device up to that one, and it only gets basically one VLAN of information across there. That end device isn't capable of looking at that 802.1 frame tag, and so we have to go in there and say, okay, you're an access port. We're going to send one VLAN of information across there, and then we're going to set that port up in the next command to listen to or search for VLAN 20 or whatever our VLAN is, VLAN 10 in this one, VLAN 10's information. First command here is we need to set this as an access port, and so that command here is switch port mode. We're going to set the mode here to access. Spell it correctly, hit enter. There we go. Now we've set all 8 of those to an access port. Now we got to say what VLAN are you going to be associated with, and we're dealing with the ports on that switch, the switch ports. And so we start off with switch port again. It is an access port setting we are dealing with, so the next keyword is access, and then it's what VLAN, so VLAN and then VLAN 10. So our command here is switch port space access space VLAN space 10 will set ports 1 through 8 up to be in VLAN 10. Go ahead, hit enter. And how do we know it worked? Well, once again, no news is good news in the Cisco world. Now we can go ahead and do the next one for switch 2. For switch 2, we have ports 9 through 16. We could type exit and then type the range command again, but instead of just typing exit, we can type the interface and it'll take us right into that. And so we have interface range fast Ethernet 0/9 and then space dash space 16. And yes, the space after the first interface, the dash and the space, those are important. So always make sure you put your space dash space in there and then your ending port number. I'm going to go ahead, hit enter. Now we can set that as a access port, switch port, changing the mode to access. And then what VLAN will it be associated with? And so that we're working with the switch port setting. So it's switch port. It is an access port. So it's access VLAN. And then what VLAN are we listening to? Or what VLAN are you going to be associated with is VLAN 20. Let's go ahead and do the last one. Range of addresses 17 to 24. Interface range F0/17 space dash space 24. Set that up as an access port, switch port mode access. And what VLAN will that be associated with? We were working with the switch port settings again. So switch port, it is an access port setting we are setting. VLAN and then VLAN 30. That set up all of the configurations for VLAN 30. If you need that in the worksheet and the instructions right here, here are the commands to do it. And then B here, assign VLANs to ports on switch 3 using the assignments from above. Let's go ahead and do the same thing, but for switch 3. Right here, we have our settings. I'm going to go ahead and minimize switch 2, click on switch 3, get into global configuration mode, config T. Now we can do our interface range command. So interface range F0/ and then our range here from our table is 1 to 8. So 1 space dash space 8. Once again, notice our prompt has changed. We're doing an interface range here. We have to set that mode to an access port. So we look at switch port mode access. Then what VLAN will that be associated with? Up here it is VLAN 10 for ports 1 through 8. Switch port access, because it is an access switch or access port, we are setting those access parameters. What VLAN? So VLAN and then 10. Now we can change to the second range of addresses, which is right here, 9 to 16. Interface range F0/9 space dash space 16. Set them up to be an access port, switch port mode access. And then what VLAN will they be associated with? Switch port access VLAN 20, right? Yep, VLAN 20. And then we can do our last range of addresses here on switch 3. It's 17 to 24. Interface range F0/17 space dash space 24. Set it up as an access port, switch port mode access. And then what VLAN are we going to listen to? Switch port access VLAN 30. That looks good. That should take care of the first part of B here. Now that you have the ports and the assigned VLANs, try to ping from PC1 to PC6. PC1 is right here. I'm going to go ahead and click on it, open up my command prompt, scroll up to my addressing table, and we are looking for PC6, which is right here. PC1 to 6. If we look at, they are on the same network. So the third octet is the same between them. Okay, ping, and our IP address here once again is 192.168.10.2. 192.168.10.2. And is it going to work? Is this an ARP request, or are we actually failing in our connection? ARP requests are actually failing. Second one, third one, and probably get a fourth failure. We got a failure. So it is a complete failure going from PC1, which we're on, trying to ping PC6. Now, why did that fail? If we look down here, that's our question. Was the ping successful? No, it was not successful. Explain why. Okay, we have set PC1, the port it connects into, onto the switch, F01 here. We set that into VLAN 10. On switch 3, we have also set that into port 8. Where if we look at our range, once again, 1 to 8 is all VLAN 10, so they're both PC1 and PC6 is in VLAN 10. But when you first turn on your devices and there's no configuration on them, the switches all create access ports. And so this connection right here, and this second connection right here, those are access ports. Now, in order to get this VLAN worth of information across here, we have multiple VLANs. We got 10, 20, and 30 here. In order to get that across here, these can't be access ports. These need to be trunk ports. Trunk ports handle multiple VLANs of information. They handle the 802.1q frame tagging, where they put that little header in that frame to identify what VLAN that is. An access connection doesn't do that. We need a trunk port. And so this traffic, or these connections here, are set up as access. What we need is trunk ports, and that's why. And so our answer here is, this is because the ports that are connected to the switches are not configured as trunk ports. You carry traffic from multiple VLANs. I hope you're liking this episode on practical configuration examples. Leave a comment on what you think about these configuration examples. If you still have a question or comment, please let me know below. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. On to part 4, we're going to configure the trunks on S1, S2, and S3. DTP, Dynamic Trunking Protocol, manages the trunks between Cisco switches. Once again, DTP is a proprietary protocol for Cisco switches. They configured that trunking there. It's proprietary. No other devices have that besides Cisco. So if you have a complete Cisco network, DTP is going to work beautifully for you. Currently, all the switch ports are in the default trunking mode, which is Dynamic Auto. In this step, you will change the trunking mode to Dynamic Desirable. For the link between switches 1 and 2, the link between switch 1 and 3 will be set as a static trunk. Use VLAN 99 as the native VLAN in this topology. And so right here, we're going to set this up as Dynamic Desirable, and they're going to try and negotiate a trunk connection. This connection right here, we're going to set up as a static trunk. We're going to say your trunk, there's no configuration or there's no negotiation that's going to happen. You are just a trunk. Step 4A, on switch 1, configure the trunk to link desirable on gig Ethernet 01. The configuration of S1 is shown below. Okay, let's connect into S1. You have to log in, hit enter, type enable to get into privilege exec mode, config T to get into global configuration mode. Now, we go into interface G0/1. And then our command here is, once again, we're dealing with the switch ports. So it's switch. Okay, I got to spell switch port right. Switch port. And then we're changing the mode. Just like we change it into mode access or mode trunk, here we're going to change it into mode dynamic. So mode dynamic. And then we want Dynamic Desirable to have it negotiate for a trunk. Desirable. Notice the interface now, it went up, but then it went down right away. We bring it down to make the changes to it because we made a change to the mode, and then we bring it up right away. And then because we brought this up, our line, or our VLAN 99 also came up at that point in time. What will be the result of the trunk negotiation between switch 1 and switch 2? When we look here, we change this to Dynamic Desirable, meaning it wants to be a trunk. Down here, the default again was Dynamic Auto, meaning I'm going to try to do kind of whatever, but odds are I'm going to get back to an access port. But because this is Dynamic Desirable, we are going to try our best to get a trunk connection. Dynamic auto is kind of like, hey, I'm here. We're going to try to do a negotiation, but I'm not really going to push for it. Dynamic desirable, on the other hand, hey, we're pushing for your trunk connection. And so we should get a trunk connection right here. The answer to our question, what will be the result of the trunk negotiation? The trunk will be successfully negotiated because the port on S2 is in the default dynamic auto mode. Change that to switch 2. On switch 2, verify that the trunk has been negotiated by entering the show interfaces trunk command. Interface G01 should appear in the output. Okay, I'm going to go into switch 2, log in by hitting enter, type enabled to get us into privilege exec mode. Now I can do the show interfaces trunk command, and there we have gig 01 set to auto. We're using the 802.1 encapsulation, and it is trunking. The status is trunking. We have successfully negotiated the trunking. What is the mode and the status for the port? The switch port is in auto mode, which is the default. The port is trunking. That takes care of part 4B on the 4C. For the trunk link between S1 and S3, configure the gigabit Ethernet 2 gigabit Ethernet 2 as a static trunk link on S1. In addition, disable DTP negotiation on the G02 interface on S1. Okay, so on S1, I'm going to go ahead and minimize S2, get back into S1 right here, exit out, take me into global configuration mode. Now, first thing they want us to do is set it up as a static trunk. That's where we're going and set the mode as a trunk. We are in global configuration mode. We need to go into our interface G0/2. Now we need to set that as a trunk. So we're looking at the switch port settings. We're setting the mode as trunk. So it's switch port mode trunk. Notice we take it down and then it comes back up. When we go down, we make the changes to it, to the port saying you're going to be a trunk. We bring it back up. And so we're up and we're running. And then the last thing we have to do is disable DTP negotiation. In order to disable that negotiation, that's another switch port we're dealing in our switch port, and we put the non-negotiate in there. And so it's switch port non-negotiate. Make sure I spelt it right. Non-negotiate. That disabled our dynamic trunking protocol. Onto D. Use the show DTP command to verify the status of DTP, our dynamic trunking protocol. That needs to be done in the privilege exec mode. We are currently in the interface configuration. Type exit once. Take us to global configuration. Type exit a second time into privilege exec mode. Then we can type in show DTP. When we type in show DTP, sending hello packets every 60 seconds. Dynamic trunking protocol is 300 seconds. One interface is using DTP. Which one's using DTP? That was Gigabit Ethernet 01. We disabled it on 2. Otherwise, we'd have 2 ports using it. Verify trunking is enabled on all the switches using the show interface command. So here on switch 1, we're going to go ahead and use the show interface trunk command. Gig 01 is set to be desirable. That was our dynamic desirable using 802.1q, and the status is trunking. Gig 02 is using 802.1q. It's on, meaning we forced it. We set the mode to trunk. It doesn't go through any negotiations at all. And the status is trunking also. Let's go ahead and check switch 2. Even though it's right there, we'll do the show interface trunk command again, just to verify it's still up and running. Gig 01 is an auto using 802.1q and is trunking. I'm going to minimize S2, bring up S3, enable to get into privilege exec mode, and then show interface trunk. And our gig 02 is set to 802.1q trunking. All three of our switches have the trunking ports on there. What are the native VLANs for these trunks currently? The native VLANs for these trunks, if we look right here, we can see that the native VLAN is 1. That's on switch 3. Switch 2, native VLAN is 1. And if we look at switch 1, native VLAN is both 1 and 1. So the native VLAN is 1 for those. VLAN 1. Configure VLAN 99 as the native VLAN for the trunk on S1. Okay, we are on S1 right now. We need to get into global configuration mode by typing config T. We have two interfaces, so we can use the range command, gig 01 and gig 02. That would be interface range gig 0/1. Then we got to make sure we put our space, a dash, and a space in there, and then our ending port number. And now any command we type in here will apply to that range of port numbers. And then we need to set up our native VLAN. Once again, the native VLAN is for our untagged traffic. Sometimes with legacy equipment, proprietary equipment, or even if you're using a hub, traffic can get on your network that doesn't have an 802.1q frame tag. It doesn't say what VLAN it belongs to. If it doesn't have the 802.1 frame tagging on it, it puts it into the native VLAN. And so that is a switch port setting again, because we're dealing with the switch ports as a per port setting. It is part of the trunk setting, so it's switch port trunk. And then we say native VLAN, and then what is the number of it? The number was 999. Go ahead, press enter. We have now set our native VLAN. But we did get some errors here. We have a spanning tree, inconsistent peer VLAN ID on gigabit Ethernet 01 with VLAN 99. We also get a native VLAN mismatch error saying between gigabit Ethernet 0199 on our switch and with switch 2 gigabit Ethernet 01. So on switch 2, the other side of our trunk connection on switch 2, that's set to VLAN 1 as our default VLAN. Once again, the default native VLAN is VLAN 1. We changed the native VLAN on switch 1, but we didn't change it on the other two, on switch 2 or switch 3. That's what's giving us our native VLAN mismatch error. So what message did we receive? We received a native VLAN mismatch error. How do we correct that? Well, we have to go into the other two devices and change it to the correct native VLAN, which is 999. On S2 and S3, set the native VLAN to 999. On switch 2 and 3, configure VLAN 99 as the native VLAN. So what we have to do is go into those interfaces on switch 2 and 3 and set the native VLAN is 999. Okay, I'm going to go ahead and minimize S1. I'm going to connect into S2. If we notice, we have our native VLAN mismatch error popping up here. Get into global configuration mode, config T. Our trunk port here was gig 01. And so we can go into our interface gig 01. Interface gig 0/1. And then we can go ahead and type in our command to set the native VLAN. And that was part of our switch port settings. We are working on some trunk settings. Native VLAN 999. I set that to 999. And hopefully those errors have stopped. Now that we have that corrected. Looks like they have. We haven't got one popped up. Let's go ahead and do S3 quickly. Click on S3. Notice once again we have our native VLAN mismatch errors. Get into global configuration mode, config T. Our trunk here was gigabit Ethernet 02. So we can go ahead and get right in that interface. Interface gig 0/2. And then we can go ahead and set our native VLAN. Switch port, trunk, native VLAN 999. That command looks good. I hit enter. Now, when I did that, notice that we have now changed from unblocking. We were blocking, we're unblocking. And we have port consistency restored. That means we did something good. That means we do have this matching VLANs on both ends of our trunking. Now, the trunk between S1 and S2, they have native VLAN 999 on each end. On switch 1, or the connection between switch 1 and switch 3, right here, we also have the correct native VLAN set on both ends as 99999. Verified trunking is successfully connected on the switches. You should be able to ping one switch from another in the topology using the IP addresses configured in the SVI. And so what I'm going to do is I'm going to open up SV1 here. I hit enter a couple times, give me a clear working area. That way I can tell if I get another error message popping up that it will be after that. Because right now it's kind of hard to tell when these messages did pop up. But let's go ahead and ping the other switches. And so I got to get out of this interface range configuration, type in exit once, get into privilege executive mode, type exit a second time. Now I can go ahead and type ping. I'm going to scroll up to our addressing table. We are on switch 1, so this is our IP address. Let's go ahead and ping the IP address on switch 2, 192.168.99.2, 192.168.99.2. Looks like once again the Cisco iOS sends out 5 pings, and the first 2 failed. I'm guessing it had to do ARP lookup, address resolution protocol, figure out what the MAC addresses are. If we repeat that command, up arrow once, hit enter, all 5 successfully work. Let's go ahead and ping switch 3's SVI. Here's the switch 3, the SVI 192.168.99.3, 192.168.99.3, but I missed a period in there. I got a left arrow back. Put my period in and now hit enter. Hopefully we're gonna do some ARP lookups here, fail, and then it works again. If I up arrow once, hit enter to repeat that command, all 5 work. So now all of our SVIs, all of our switches are able to communicate with each other. Let's scroll on down here. Attempt to ping from PC1 to PC6. Was that ping successful? Okay, so we are going from PC1 to PC6. I'm going to click on PC1 here, type in ping, get the IP address for PC6. We have 192.168.10.2. 192.168.10.2. Okay, we are failing. We have 4 failures. It's not an ARP lookup. We definitely still failed. Was the ping successful? No, it definitely wasn't successful. Let's go ahead and type no. Hint, look at the show VLAN brief output from all 3 switches. Compare the outputs from the show interface trunk on all 3 switches. Okay. So first one, let's go ahead and do the show VLAN brief on all 3 switches. S1 right here. Show VLAN brief. We have VLANs 1, 99, 999, and 1002, 1003, 1004, 1005. Then let's look at show VLAN brief here on switch 2. Type exit once, exit twice. Show VLAN brief. We have VLAN 1. We got 10, 20, 30. That was missing on S1, but it's on S2. Then we have our 99 and 999 there, but 10, 20, and 30, that was missing on S1. Let's go ahead and look at S3 again. S3, type exit once, type exit the second time. We can do a show VLAN brief. And here's our VLANs 10, 20, and 30. 10, 20, and 30. And so switch 2 and 3 right here, they have VLANs 10, 30, or sorry, 10, 20, and 30, which are end devices. They belong to that, but switch 2 does not have that. What's happening here is PC1 is in VLAN 10. It sends its information to switch 2. Switch 2 adds in that 802.1 tagging saying, hey, you belong to VLAN 10. It adds that field in that frame header. It gets up to S1, and VLAN 10 does not exist up here in S1. Because it doesn't exist through up here, it doesn't make it through the switch. Now, on S1, we don't have to have VLAN connected to an end device here on that. Just VLAN 10 needs to exist. There doesn't need to be any ports or devices in VLAN 10 on switch 1. It just needs to exist, so that way we can send VLAN 10's worth of information through that switch. So was the ping successful? No, because VLAN 10, 20, and 30 does not exist on S1. How do we fix that? Well, we're going to have to go in and create those VLANs on S1. So step J here is correct the information. Let's go ahead and go into S1 here. We are in privilege exec mode. I'm going to go ahead and type in config T to get us into global configuration mode, and then we just have to create those VLANs. I'm going to scroll up to make sure I get the right VLAN information. Here's our table. VLAN 10 is called red, 20 is called blue, and 30 is called yellow. All we have to do is create them. And so we can type in VLAN space 10. Our prompt changes saying we're configuring a VLAN. We can name it at this point in time. Name red. Now, technically you wouldn't have to name it just as long as it exists, but I find naming it helps. That way, if you ever have to come back to it, you can say, oh yeah, that is our red VLAN, or that's the VLAN connected to our HR or our counting. Go ahead and name it. Then we can go into VLAN 20, create and enter it. Name that capital B blue. And we can create and enter VLAN 30. We can name that capital Y yellow. Correct as necessary. Now let's go ahead and just try pinging 1 to 6. Ping 1 to 6. Once again, that IP address was 192.168.10.2. And now that we have trunk connections between switch 1 and switch 2, switch 1 and switch 3, VLANs 10, 20, and 30 exist on switch 1 and all the switches, we are now able to successfully ping from one PC to another that is on the same VLAN. On to part 5, reconfigure the trunk on S3. Issue the show interface trunk command on S3. Let's get into S3. Show interface trunk. I spelled trunk correctly. What is the mode and encapsulation on G2? The mode is auto and encapsulation is 802.1q. Configure G2 to match G2 on S1. Okay, so I'm gonna slide the S3 window over here. I need to make it match G2 on S1. I'm gonna go ahead and open up S1 here. Exit once, exit twice to get into privilege exec mode. I'm gonna do the show interface trunk. And so what we have here is it's set to on in 802.1q trunking. What we have to do is we have to disable DTP and we have to say you are a trunk. We have to set it to a static trunk. Now we need to go into G02 interface on S3. So I'm in the S3 window. Make sure you are on S3. Get into global configuration mode by typing config T. Get into our interface of gig 0/2. Once we're in that interface, we set the mode to trunk, so switch port. I gotta spell switch port correctly. Once again, make sure you are on switch 3. So switch port mode trunk. Set that to trunk. And then we have to disable DTP, dynamic trunking protocol. We set it to non-negotiate. And that command is switch port non-negotiate. Non-negotiate, make sure you spell it right. That looks good. And there we go. I'm going to slide this back. What is the mode and encapsulation on G2 after the change? Well, let's go ahead, exit out to get us in the global configuration mode. Exit out a second time. Let's go ahead and type the show interface trunk command. We are now on, and the encapsulation is 802.1q. The mode is on, and encapsulation is 802.1q. Issue the command show interfaces G02 switch port on S3. What is the negotiation of the trunk state displayed? Okay, the command is show interface G0/2 switch port. What is the negotiation of trunk set to? Here's our negotiation of trunk. It is set to off. That's because we did that non-negotiate. We turned off dynamic trunking tree protocol. It's not going to do any negotiation. It is off. Part 6 here. Let's verify end-to-end connectivity. And from PC1 to PC6. PC1 right here to PC6. Go to my addressing table. PC6 IP address is right there. Ping 192.168.10.2. That successfully works. Then we have to ping PC2. Let's go ahead and open up PC2. Get into our command prompt. Ping, and then get the IP address for PC5 from our addressing table up on top. PC5's IP address 192.168.20.2. 192.168.20.2. That successfully works. And the last one from PC3. Go ahead and open up PC3. Get into the command prompt. Ping. And then I need the IP address of PC4. PC4's IP address is 192.168.30.2, 192.168.30.2, and that works. Here we go. The 3 pings all work between all the PCs. That was Packet Tracer Lab 3.5.5 Configure DTP, Dynamic Trunking Protocol. It was my pleasure to provide you with this wonderful episode on configuration examples. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. Thank you so much for watching this episode of my series on practical configuration examples for the CCNA. I've created 4 wonderful playlists for you on the CCNA. These episodes, I go through all the concepts that Cisco calls out for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.